Terrence Bolt, a distinguished professor emeritus from University of Colorado Springs. And my talk is on calculator confusion, navigating cardiovascular risk models on keto. I don't have much social media presence, but the code from this talk and the talk itself is on GitHub, in my GitHub account. Start off by saying I have no financial conflicts of interest. I have lots of interest. I got very interested in maintaining my health, and I find lots of conflicts in the metabolic space and health space, and so I'm trying to resolve those, and that's what got me down this path. I got into keto because a second friend of mine got diagnosed with type 2 diabetes, and this one, his doctor told him to go look at the science behind the ketogenic diet and use that to try and resolve his diabetes. Told me, I went home, read 50 papers over the weekend, and decided the science was very strong and I was going down this path. But I had one concern, which was, what is it going to do to my ASCVD risk? So I've been looking at calculators to try and understand what's going on. I started out looking at the pooled cohort equations that underlie the calculator you can find in the American College of Cardiology. You can see here some of my numbers before keto, my cholesterol, blood pressure numbers. Putting that into the calculator, my risk was 17.5%. I have a family history, so I wanted to start taking care of this. That's a picture of me in the lower left. I was a little overweight. Jumped on keto, lost most of the weight in 3 months, but 9 months later I had my next set of labs. You can see now my cholesterol went up, but my HDL went up even more. My blood pressure went down. I actually ended up getting off my blood pressure meds within about 3 weeks of keto. And now my risk was 7.5. If I look at the trigs, the HDL that many people like to look at in the keto space, it was 5.5, went down to 1. So both of these show reduced risk depending no matter how you want to look at what's going on. But that's an old calculator, so I went in 2023, a new Prevent calculator came out. I went, plugged my numbers in this instantly. It's a different calculator. I have lower risk, even pre-keto was down to 12.5. But if I plug my post-keto numbers in, I'm down to 5.7. The Prevent calculator allows me to include my A1C and zip code. I put all that in. I was down to 4.2 risk, which overall looks pretty good. So I went from pre-keto having a 12.5. Now I'm down to a 4.2 after 9 months of keto. It reduced my risk. So here's my first takeaway from this talk. Don't presume that keto will increase your risk just because your cholesterol will increase. Even though it did go up, keto significantly reduced my projected risk. Risk calculators like this may help you or others be much more comfortable with the keto decision. If you can improve your blood pressure, improve your HDL, improve your A1C, all of these might actually lower your risk more than the increase in HDL. Now, when I look at models, I've done modeling for a long time. I worked on heart models back in the 90s. All models are wrong, but some are useful. It's a nice statistics quote. And let's examine how I've been able to use these and examine that with respect to cardiovascular risk calculators. They're all models. So one of the things I did is I went and looked at the U-Prevent, which is a 2018 model from the EU. And one of the nice things about this calculator is it actually has some projected, what if I do certain kinds of things? So what if calculations. For absolute risk reductions, if I wanted a Mediterranean diet, it projected would reduce my risk by 1.4. Absolute risk for 10 years. 2 different statin dosages, ezetimibe, antithrombotics like taking aspirin. All of these are things that I might do to reduce my risk, and I can ask what is the expected effect. So I looked at that and said, sure, I can do a Mediterranean low carb. So I did that. I did a Mediterranean low carb, and then this was another 4 or 5 months later, I got my next set of blood work in, and you can sort of see my new parameters, cholesterol, blood pressure. Blood pressure went back up to 120. It started creeping back up. Even though I was still low carb enough, my A1C went down to 5.2, so I was still continuing low carb, but not quite strict keto. My risk went up to 4.9 using the Prevent calculator. So even though one calculator said it would be better, my actual numbers didn't improve. Now, the next thing that happened is, because of my family history, I decided to go get a CAC score. I was hoping for that power of zero, not zero. I got a 75%, 339. So I decided to be more aggressive based on, again, what I'd seen in the U-Prevent. I went and did statins. So I took rosuvastatin 5 milligrams. I was able to drop my cholesterol down to 130, but my HDL dropped as well. My blood pressure, now I had to get back on blood pressure meds, even though I was continuing to be low carb enough to get my A1C down to 5.1. but putting all those numbers in the calculator, my risk was now 5.1. So this did not further decrease my risk. According to the Prevent calculator, it had increased my risk. And the H1 HDL going down is the part of the driver here. The blood pressure going up is another driver. Not everyone will have these kinds of effects. HDL, for some people, goes up on rosuvastatin. For others, it goes down. It's about 40%. See a decrease, an increase in HDL. So I'm falling in that not very good category. I actually looked at a whole bunch of other calculators. So this is now more recent blood work after 26 months on keto. So I'm going to look across these calculators. I actually looked at another 10 that aren't on here, or 8 more. And I have 3 lines on this chart. So the first blue line is where I did keto with no meds. And the other 2 are, again, going back to my experiments with 1 medication or 2 medications and looking at those numbers and sort of seeing what would happen. I've done this experiment twice now. In all these cases, my A1C is now pretty consistently 1.5, but I've been able to go back on and off if I add blood pressure meds or statins and see what happens. So the first thing to note is keto, for all but one of these calculators, was the lowest risk, whether or not it took statins, and blood pressure medicines. Prevent is the only one that has a slightly lower value with statins because it has a very strong statin bonus. Coming back to the understanding what's going on, being able to set up and look through these gives me one good feeling, which is that now I have a whole bunch of different models and they all agree that keto was better for my risk in general. Not everyone, but so it gets around some of the questions of model artifacts. But so my takeaway number 2, use the most up-to-date calculator with the most relevant information for you. Don't just presume because it said it would do this, it would lower my risk. Do N-of-1 experiments on what your lifestyle choices do to you, and then test, don't guess, recalculate your risks. So I expected statins would reduce my risk. I expected Mediterranean would reduce my risk. It did not. Some of that might be because in the studies where they went to Mediterranean, they looked at people who were on the standard diet, and switching to Mediterranean for that is a boost. But keto might be an even better diet, at least for me. So understand what it does to your physiology and then go on. Now I want to dig a little bit deeper because I got very interested in what these calculators were telling me and how to optimize my parameters. So here I'm going to show you some heat sensitivity maps. In each of these maps, total cholesterol is on the bottom, the x-axis going from left to right. And then the vertical axis show different things. So the upper left quadrant is showing what's happening with cholesterol, HDL cholesterol. And so as HDL cholesterol goes up, my risk goes down. These black lines in here are lines of equal risk. So you can actually sort of see the trade-off. As I increase my total cholesterol, my HDL, my total cholesterol will go up as well, but it goes up much more slowly. We'll come back to that in a bit. The second cell here is systolic blood pressure, and you can sort of see this as the inverse effect. Decreasing my blood pressure decreases my risk, and there's again a trade-off. If I can lower my blood pressure at the cost of keto increasing my cholesterol a little bit, that's okay. There's a trade-off there. HSCRP, this is the Astrotrum calculator. It includes measure of inflammation. Again, steep decrease as I can trade off HSCRP for cholesterol. Very different units, but there's still a nice trade-off there. The bottom 2 are showing CAC score and age, which really are things I can't control, but I like to be able to look and say, well, what happens if my CAC score increases, and how much do I have to deal with it as I age, because age is just going to keep progressing. So the bottom right-hand side, where that little pink arrow is, shows you sort of the model coefficients in the regression, the beta, and then the ratio of 1 beta to the total cholesterol. So if I look at HDL, the ratio is -10. And what that tells me is that 10 units decrease in, 1 unit increase in HDL is worth 10 units of cholesterol. That ratio says what my trade-off is. So if I can raise my HDL by 10 units, that's equivalent to reducing my cholesterol by 100 units. And so in all of these, I can look at this. When I first did this talk, the HSCRP, I looked at it 50 times is a much greater impact. But it's a very different news. So you have to be very careful how to compare these. Total risk reduction is a complex trade-off between these. Obviously, the CAC is the largest thing. I will point out if anyone tries to reproduce these, I've released the code in part because the paper has the model coefficients printed wrong. There's a typo. The calculator has the LNC for coefficient is off by having a leading zero, and it shouldn't. That made things really bad. So I got it fixed up. But there's an online version of the calculator. You'll notice some black dotted lines going up these. That's at 300. That's where the actual calculator was ended its calibration. So that's all the normal calculator would do. But because people on the ketogenic diet often have much higher levels of cholesterol, I extended my plots to the right to sort of go what's going on. Both Prevent and Astrotron say we're going to stop you at this upper limit, but you can just fill in the upper limit and use it as an estimate. It's like, why would I do that? These are increasing, coefficients. Right. Assuming I just truncate to the right-hand side is a bad idea no matter what I'm doing. So I'm going to extend them and allow myself to use other information. Now, I'm going to come back to the numbers. I didn't show you one thing. When I was going through this Prevent calculator before, I told you I could add A1C, my zip code. Well, if I take away my zip code, I got some very weird behavior. And this is what made me start digging, get very confused and had to dig deeper. If I take away my zip code, the risks went up. Not surprising because it doesn't know where I live is a good environment. But also the risk for including A1C actually increased my risk instead of going down. I was very confused. How could that be? 5.4 is still a decent A1C. So as I dug into the model, and I'll show you some more in a second, Prevent really isn't one model. It's about 100 different 23-dimensional regressions with formulas that choose between and combine different models and different coefficients and intercepts. And if you by not including zip code, you instantly switch to a new map that has very different results. And some of the difference between these maps are very significant, like 40 to 70% difference in slopes of these things. So the beta coefficients change a lot as you go between these different maps, and it's hard to understand what's going on. But Prevent is not just a 10-year calculator. There's 100 is they do ASCVD, heart failure risk, and then they have 10-year and 30-year. So there's a whole bunch of things you can get out of it. But even for just the basic total CVD risk, it's complicated. So I'm going to show you some maps. So these are the same kind of heat maps that I showed you for Astrocharm. HDL and SBP are actually in the same area, but here I'm going to show you 4 other maps because these are other variables that go into it. EGFR, your social SDI, which comes from your zip code, your socio-demographic indicator, HbA1c, and UARC. So I'm going through these different maps, and you can sort of see how much they're changing. And all I'm doing is changing what variables are provided. So whether I have 2 variables of this one or that one, and you can see maps are changing a lot. And that's part of the problem with this is they're going to be very unstable. One thing to look at UARC, the bottom left-hand side, there's a lot of interesting stuff going on below 10 for UARCR, but most labs can't measure that. So you end up getting something where you can't get that. So I would actually end up leaving this as the sort of map I would use the most often. It's got everything except for UACR because I can't measure it in the resolution they would need. I started looking across different implementations of this, and there are a couple online. They radically differ in where their errors are and what they're doing. They're not all implementing it. Having implemented it myself, it's a lot of work to get to. The reference implementation does not match the reference Excel sheets that came with the paper, don't match what's in their online calculator. Can't exactly figure out exactly what's going on. So looking at these other calculators is important, but the errors are pretty significant. So when I go look at this, there's a couple of other interesting artifacts to point out, like this weird structure going on here in systolic blood pressure. You can see how much the slopes vary depending where in the maps you are. All of these are interesting trade-offs that you can get into to try and look at what I want to do to optimize it. So one of the things I did for myself is I played some what-if games using this. So I asked, what if I were to increase my HDL to 90, my systolic blood pressure would go down to 110 without meds, but in doing so, I became a lean mass hyperresponder with a total cholesterol of 300. From where I'm at now, what would that be? Yeah, I was about to retire and move, so that's actually why I dropped the SDI. I wasn't sure what happened. What does a good SDI do for me? So what if I take Satan? So these are some what-if questions. And by using my tool, I can go in and look at this. So the first thing to note is that if I look at the cholesterol, raising my total cholesterol from where it is now, around 130 to 300, or 180 to 300, gives me a 0.3 increase in risk. Dropping my blood pressure, right, gives me a 1 one unit decrease. Raising my HDL gives me 0.8. This combination. So if I were to decide to go intentionally become a lean mass hyperresponder, get my cholesterol up to 300, I would have a net decrease in risk, according to the AstroCharm model, of 1.5. This number is actually even lower for the cholesterol increase in the prevent model. Prevent is a bunch of trade-offs. So in this case, my risk would only go up a little bit from increasing my cholesterol from 183 to 300. I would have a smaller decrease from the blood pressure and a HDL increase, but they're still much larger than the total cholesterol. If I can reduce my HbA1c down to 4.9, which I've actually already done by being a little more strict in my keto, I get another 0.1, so that completely offset the cholesterol as well. The zip code bonus for where I've moved to, right, is 2.8, so it's huge. It's much larger than everything else. I actually attribute this to the fact that the SDI bonus is really getting a whole bunch of other factors in about your quality of life, but your quality of medical care, but probably a little health user bias that we tend to live in better environments and whatever. So, but overall, if I didn't take statins, this gives me a 3.5% decrease from where I'm at pretty much now. The 6.9 is because I didn't include my previous SDI. It's not the change that matters. But if I wanted to add statins, the other interesting thing is that there's a statin bonus. And the statin bonus is 0.5. Just if I take a statin, whether or not it's working, 0.5. So if I take a statin and I can get my cholesterol back down to 189 or 200 from the 300, I'll get a 0.4. If I got it down even lower to 130, it would be a larger increase. But these bonuses help reduce it even more. So I can look at this and say, well, would statins optimize this? Now I have to be a little careful with prevent because it's formally not for people with CACs as high as mine. The CAC drives me to depend more on the AstroCharm model because prevent says don't use it if your CAC is greater than 300. But just in putting it in context, if my CAC had been 0, I would actually still have a lower AstroCharm risk because it would be down to 1.7, lower than the prevent risk. So CAC is a direct measure of what you have going on in your heart. It's a much better matter. Now, I did this using my own tools, and I can dig in deep, and you might want to hack Python. You're welcome to get my code and play with it. But if you don't, there's another version of the prevent calculator from ClinCalc, and this one allows you to do some of the what if I just went through. It'll show you the percentages of what different things do. So if I put in pretty much the same statin example I gave you, it shows you how much you get from reduction from the statin, from the HDL, the cholesterol. All the green bars are things that helped you. Anti-hypertensive, the fact that I'm taking blood pressure meds increases my risk. And then my age, which is a big factor, which I didn't include in the previous shot. But so coming back to the end of the talk, my takeaway now through which calculator should you use? And the answer is, well, it depends. In my view, AstroCharm is by far the best calculator. If you're on keto and you have CAC, because it's got COC built into it, which is a direct measure of what's going on in your arteries, I would recommend prevent, and it's especially useful when you have the SDI and you have good metabolic control, HbA1c, EFGR, UCAR. All of these are things it helps manage. I find it useful for planning, but it ignores CAC. If you're across the pond, UPrevent is the calculator I would recommend. QRisk in the UK is there, but I find it very pessimistic. It doesn't have as much metabolic information. For those people who have Lp(a) issues, there's actually an LPA clinicguidance.com has a calculator that includes LPA, which can be useful because you have a very unique situation. For those thinking about CAC, there's the older MESA calculator, which gave me a much higher 17% risk. I view this as sort of an older anatomical thing. It includes CAC, but it doesn't have any of the inflammation stuff that AstroCharm does, so it's going to miss all of the healthy bias you get from having very low inflammation. There is the pooled cohort legacy, which really isn't recommended, in my view, for anyone on keto. It's what's on the cardiovascular risk calculator, or American College of Cardiology's website. My understanding is they're going to change over to prevent this year. We'll see if that actually happens. There's been some contention because it doesn't always reduce statins, and people are worried they'll stop deprescribing them. But all these models show that keto lowered my risk, but they're also all trained on normal populations. Likely there was only a few low-carb people, so they may not apply to people on keto at all, so we have to be a little careful using these models. All models are wrong, some are useful. Use them, make some decisions, but they might help you decide that keto actually lowered my risk. If there were more low carb people, it might actually have been even better, but that's what I have. So my last recommendation is choose the calculator that fits the context, what you know, and the question. Obviously, EU, American, different geographic context to understand what's going on. So I end up with some questions for the audience. We have a wide divergence in calculators. Why don't we build a model that includes the metabolic information, the SDI, and the CC elements, only one big model that has all of them? So prevent with CAT, right? Why don't we have that? And then I have some different questions. Some of these things like the systolic blood pressure, there's a bonus for having low blood pressure, but a negative for having medication. HDL, we know there's been studies that tried to raise HDL, it didn't actually change risk much. Are these, and the statins, right, are these really operational risk levers, or are they really historical models or just model artifacts that is sick people get a real benefit from some of these? Is the SPB medication impact, is it really a function of history, or is it a real-time effect? How does sodium, there's a whole bunch of things that we could stick into calculators to try and understand that I'm still looking at. So my slides are up on GitHub. The code for AstroCharm, my version of it is there, and the Prevent will be there soon. So thank you for your time.